Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. These days we are discussing panel data methods, and today we will discuss the tests related to post-estimation process in applying panel data techniques. तो ये जो panel data methods आप कर रहे हैं, इसमें हमने fixed effect भी किए, इसमें हमने random effect भी किए. आज इनकी practice करेंगे और हम देखेंगे कि regressions run करने के बाद कौन से tests हैं जो हम apply कर सकते हैं. For example, we can apply the tests for heteroscedasticity, for autocorrelation or serial correlation. We can check for multicollinearity. We can check for stationarity. We can check for cross-sectional correlations or time fixed effects and many other things. So some of them will be performed today, and we will discuss them one by one by taking two different examples. So in the first example, we'll go through in a little detail, and the second example is a short one. So to make you understand what steps should you perform while you apply the panel data techniques, whether random or fixed effect or any other model. So first of all, we start by using a file available with Stata or shipped with Stata. It is called NLS work. So you will download the file, or you will use the command web use NLS work clear. So when you use the command web use, a file will be loaded in your memory, and you will see the result as variable names on the right side in the variable window. So the first step that you perform is write web use NLS work clear, and then you will have a variable list that is shown on the screen. The variable list includes, the first one is ID code. This will be the entity or individual variable which will identify the cross-sectional dimension of the panel. Then you have a variable year. This will identify the time dimension. And you have many variables. For example, you will have log of wages, see at the end. You have grades, you have race, age. You have dummy variables like South and Union. So look at South. It is 1 if the respondent resides in the South. The dummy's value is 1, otherwise 0. Similarly, if the respondent is member of the Union, 1 is the value of the variable Union. So you have different variables. So you know, when we apply any model, regression or panel data techniques or whatever, you first want to know what the data contains, what the file contains. And you remember we use the commands summarize, describe, tab stat, etc. and tab, tabulate to know your data. So first let's know our data, and then we will apply various techniques of panel data methods. So as you remember, when you have a panel data, you need to identify it as a panel data by using the xtset command. You need to give a variable for the cross-sectional dimension and the variable for the time dimension. So आपके पास बुनियादी तौर पर दो वेरिएबल होने चाहिए, एक वो जो क्रॉस सेक्शनल डायमेंशन को आइडेंटिफाई करे और दूसरा जो टाइम डायमेंशन को आइडेंटिफाई करे. याद रखिए कि ये वेरिएबल्स न्यूमेरिक होने चाहिए. मिसाल के तौर पे अगर आपके पास इंडिविजुअल एंटिटीज़ कुछ मुल्क हैं जैसे पाकिस्तान, इंडिया, श्रीलंका, तो आपको एक नया कॉलम, एक नया वेरिएबल क्रिएट करना पड़ेगा which encodes these countries, say 1 for Pakistan, 2 for India and so on, to have a numeric variable. क्योंकि आप numeric variable को ही operations में इस्तेमाल कर सकते हैं. तो यहाँ भी हम जब xtset individual entity और time entity की command use करेंगे, तो उसके लिए ज़रूरी है कि ये दो variables जो आप यहाँ identify करेंगे वो numeric हों, float, integer कुछ भी हों, वो string values नहीं होनी चाहिए. तो अगर आपके पास कुछ मुल्कों के या कुछ इंडिविजुअल्स के नाम है, कुछ फर्म्स के नाम है, कुछ ऑर्गेनाइजेशंस के नाम है, तो आपको एक वेरिएबल नया क्रिएट करना चाहिए जो न्यूमेरिक इन नेचर हो. मिसाल के तौर पे स्क्रीन पे देखिए, वेब यूज एनलेस वर्क क्लियर. दिस इज द कमांड दैट आई जस्ट टोल्ड यू विच विल डाउनलोड नेशनल लॉन्गिट्यूडिनल सर्वे ऑफ यंग women from age 14 to 26. The year is 1968, quite old data, but I'm using it as an example because it is shipped with Stata and you don't need to find or download from anywhere. So when I write xtset ID code and year, so this ID code identifies the individual entity. As you see, the panel variable is ID code. It is unbalanced. Remember that balanced panel is the panel for which every entity has the same number of time variables, the same number of observations with respect to time. And an unbalanced panel has different number of observations for every individual. In this case, for every individual, you have different observations on log of wage, on race, etc. with respect to time. Some of the variables are constant with respect to time. For example, you cannot change the race of the individual, and some are not. The second thing you see is the time variable. The year is from 68 to 88, but with gaps. This means that we don't have data on continuous years. There must be some gaps in between. And then you have delta of 1 unit. So this is the change in the time dimension year. So first, to know our data, we write describe, log of wages, and tenure, age, race, south, and union. These are the variables I just selected. You can look at the data and select your, maybe you find some other variable that you are interested in. So describe some of the variables, and you see the variable names, the storage types, the display, and the variable labels. Look at the labels. The labels tell you what the data is about. So when you say log of wages, it is the log of wage to GNP deflator. So why divided by GNP deflator? To remove the effect of inflation, because you know that inflation causes problems. When you have panel data with time dimensions, the value of 100 rupees in 1 year is not the same as the value of 100 rupees in the next year. So you have to take care of that. For that, we divide usually data by the GNP deflator. As you know, in macro data, we divide by the GNP deflator to get the data in constant prices. As the examples you have been doing, we had the data from World Development Indicators, which were in constant US dollars. This means they were divided by the GNP or GDP deflator. So in this case also you are seeing that log of wages is log of wage to GNP deflator, removing the effect of inflation. Tenure is the job tenure in years. This means the number of years the person has worked in the current organization. It is not the total experience. Age is given, race is given. You have South and Union as two dummy variables. Look at the label, one if South, one if Union. So if the person is from the South, the value of the variable for him is 1. And if he is not from the South, the value will be 0. And if he is member of the Union, the value will be 1, else the value will be 0. Now remember, we used the command xtreg for running a regression on the panel data. A fixed effect one or a random effect regression, or within or between effects as you have done. So we'll write xtreg, the dependent variable, list of independent variables, and after comma we may specify whether we need a fixed effect regression or random effect regression. So you are seeing the result on the table. The result of xtreg log of wages, which is the dependent variable, we believe that, or we hypothesize that log of wages depend on tenure and age and South and Union. Age may be a proxy for the total experience of the person because it is not available here. So we have specified after comma FE, which means fixed effect. So you have the result in front of you. First of all, you have 3 types of R squares or coefficient of determination. One is within, second is the between, and third one is the overall R square. So as you have an individual dimension, fixed dimension, and between, a time dimension, and overall coefficient of determination. So you have about 19,000 observations with 4,000 different groups. So it's a large data set. So you have the F equal to 542 and probability greater than F is almost 0. It is in fact not 0, but the digits that are being displayed here are 0. It must be something like 0.00000001, but that is not displayed here. So anyway, the result shows a good fit. Then you have the first column on the left, which is your variables. Log of wages is the dependent variable. You have tenure, age, South and Union as your independent variable, and a constant term, which is your intercept, which you usually call beta naught. You have the coefficient values. Now look at the t values and the p greater than t. That is the probability at which this coefficient becomes significant. All of them are almost 0. So at 1% level of significance, we conclude that tenure, age, South, Union, all these variables really determine the log of wages. We can determine the log of wages in terms of these variables. They are significantly affecting log of wages. Now look at the coefficients. 0.017 in case of tenure. You will interpret them just as you did in ordinary least square or OLS. But this time you have 3 more additional things. Say sigma u, which is the standard deviation of residuals within the group. Then sigma of e, which is the standard deviation of overall error term. So we denote it as sigma e. Rho is the fraction of variance due to both u and I. So you have an F test which shows that is a good fit. So this was the usual xtreg function that you had been using. You ran a fixed effect model. Now what tests can be applied later? For example, in this case, we have applied a fixed effect. We have taken care for the individual effects, but maybe some time fixed effects. The fixed effects with respect to time, they are fixed with respect to time. So there is a test, but before that you have to run a regression which performs a regression by using dummies for the time variable, and there is a command in Stata that can easily do. You don't need to create those dummies. You write I dot variable name, and dummies with respect to the values of those variables are created. Let's see. Look at the statement above, xtreg log of wages and list of independent variables. You have a new thing, I dot year. This is an index of year. So if you have several years from 1971 to onwards, so you have dummies for those years, and you are seeing the coefficients which are generated for those years. So if one of the years is taken as reference, the other coefficients are the values of the dummies of year, and you have the other results which are almost the same, the coefficients. Now, as we ran this regression, we need to test whether the coefficients of year, that is the coefficients of time variable, are significant or no. Because if you conclude that the coefficients of the dummies of the year are 0, this means that there are no time fixed effects. So to test that, we have a test available in Stata. So you are seeing the test with the command test parm for maybe parameter. So I dot year is the variable showing the time dimension. So we are in fact testing for time fixed effects by this command. From the menu, click on statistics, on post estimation, and then on tests, then on test parameters. So you can do all this instead of clicking on this statistics and post estimation and tests and test parameters. So 4 or 5 clicks, you just write test param I dot year, and you will get the result which is in front of you. So 1 to 11, so we have 11 years from 1971 to 88, with there must be some gap somewhere. For example, you don't have 1974, 75, 76. So this is why the panel was unbalanced, and they may be missing values for different countries. You had gaps in these years. So if you remember, when we wrote the command xtset, we got a message that years are from 71 onward, but with gaps. So this is why it gave the message, because we have gaps. We don't have data for several years like 74, 75. So all of them are given as 71 dot year is 0, 72 dot year is 0. So our null hypothesis is that the coefficients of these time dummies are 0. So look at the value of the test, that is f is 4.36, which is significant. So probability greater than f is 0, which means that at 1% level of significance, we can reject the null hypothesis and conclude that the coefficients are not 0. This means we are suggesting to use variable for the time dimension. We should use some variables indicating the time here. Usually you will not be able to reject H0, and if you accept H0, you will be concluding that there are no time fixed effects, as you will see in the coming example as well. So the first test which we apply is testing the time fixed effects in 2 steps. One, you will run your usual xtreg, your regression in the panel, on the panel data, but you will add a variable I for index, I dot the variable that shows the time dimension, which was year in this case. When you run this regression, then you will apply the test parm command and specify I dot year, and you will test the null hypothesis of 0 coefficients of the year variables. And if you reject it, there are time fixed effects, and if you accept it, so if the value of p greater than f is above 10%, above 0.1, then you are not able to reject the H0, and you have to accept it and conclude that there are no time fixed effects. So in this case, there exist time fixed effects. The next important test is called Osman test. So we run the fixed effect regression and the random effect regression, but we need to store those results. When we have stored the results of the fixed effect model and the random effect model, then we can use the Osman test, Osman fixed random, and it will indicate which of the models is more relevant. So look at the results of this process on the screen. You see the first statement is a statement xtreg, log of wages and list of independent variables, comma, fixed effect, FE for fixed effect. Then estimate store. Estimate store is a command that will store the results of the above fixed effect regression in a variable that you will label as fixed. Otherwise, you can say F or fixed or stored result 1 or whatever variable name you like. So fixed is meaningful name. So the second regression that we run is a random effect model, say xtreg, log of wages and list of independent variables, comma, random effect. This result also must be stored by the use of estimates store command. So estimates store random. Random is the name of the variable that I have given it to store results of this random effect model into. So now we have two, you can call them macros, in which the results are stored. Fixed is the one where the fixed effect regression results are stored. Random is the one where the random effect results are stored. You will write a command Osman fixed random, and the results are in front of you. So you have the coefficients for the fixed effect model in the column 2. Column 1 is the name of the variables. And then you have random effect coefficients. Then you have the difference. And then you have the standard error. So this is tested. The hypothesis is rejected, in fact, here, because the probability greater than chi2, chi square is 0. So we reject the hypothesis and conclude that fixed effect model is better. So see the H0 above, difference in coefficients is not systematic. So if we accept this, then random effects are relevant. If we reject it, as we did now, then the fixed effect models are better. So in this example, the fixed effect models seem to be better. But there are other tests as well. For example, I want to test whether OLS is a better choice or random effects are a better choice. Do random effects exist? Or we can test for fixed effects, and later we can do tests on heteroscedasticity, serial correlation. And if you have some problems, we'll see what to do about them. Now we have a test available to check for random effects. In fact, I should say check for a choice between OLS and random effects. That is called an LM test, Bruch and Pagan LM test. So it's easy. You have a null hypothesis, as you see on the screen. Variances across entities is 0. There is no significant difference across units. There are no panel effects. This is your H0. So if you accept this H0 and there are no panel effects, then you think that OLS is better. If there are panel effects, then random effects should be considered. So the command for this test is xtTest0, as you see on the screen. xtTest0, if it doesn't work on your version of Stata, then you need to install it. It's easy. I'll tell you in a while how to do that. So if it is installed, you have to run a regression, random effect regression, but you have two prerequisites of this command. One, you have specified the panel variables. For example, you have used the xtset command and specified the ID code and year in this case. If you have done that, then you need to run a regression, a random effect regression, because this xtTest0 tests between random effect and OLS. So if you run the random effect model, then you will write xtTest0 and you will get the results to know whether random effect is better or OLS. Let's apply this to our example. So you see that we wrote a regression, ran a regression xtreg on independent variables that we have been using. After comma, we give a random effect RE. Then we have the statement xtTest0. Because we have other tests as well, xtTest1, 2, 3. They are user-derived, user-defined modules that you can download and install. So xtTest0 tests between random effect or OLS. The results are in front of you. So it is Bruch-Pagan Lagrangian multiplier test for random effects. So in this case, the p-value is 0, which enables us to reject H0, which means that there are no panel effects, and simply we can use OLS in this case. So this test also should be used in order to identify whether they are random effects or no. Now there is a concept called contemporaneous correlation or cross-sectional correlation, which you should test for. So we have an LM Bruch-Pagan test as well for this. So the process is given to you on the screen. We call it contemporaneous correlation or cross-sectional dependence. So this test is for testing cross-sectional independence in the residuals of a fixed effect regression model. So the previous test that we have done is related to random effect regression. Now we have to run a fixed effect regression as a prerequisite. So we have two prerequisites for this test. One, we have specified the panel variable and time variable by the command xtset ID code and year in this case. And second, we must run a fixed effect model. We just ran a random effect model. We can't apply this test now. We have to apply a fixed effect model and then run the test. The test is xtTest2. So this is also a user-created, user-generated module which you can download. If it is not installed, as I told you, ssc install xtTest2 is the command. So you have xtTest3 as well. You can write ssc install xtTest3. And if you don't have it in your version of Stata, it will be installed. So look at the screen, please. You have the prerequisites, xtset, and running of the fixed effect model. You have a null hypothesis. Residuals across entities are not correlated. So if you accept this, there is no contemporaneous correlation. And if you reject it, there is contemporaneous correlation. So this is basically a problem of macro panels, where macro panels have many years and few entities. But we are using an example which is not a macro panel. So what I did is I reduced the number of observations of entities. So reduce the number of observations by using the command in. So let's see how to do that. The command is xtreg log of wages, tenure, age, South Union in 1 to 25, comma FE for fixed effect. So by writing in 1 to 25, we reduce the sample, because if you apply this test on a fixed effect model ran on the complete data set, you will not get results. Try it. So here I ran the regression for 25 rows of observations and then applied the XT test 2. Remember that XT test 2 has two prerequisites. One, you have ran the XT set command. Second, you have ran the fixed effect regression. So as you see on the screen, we have two statements. One, xtreg statement, which runs a regression on 25 observations. Remember that since this was a problem of macro panels, the test wouldn't be successful if you run it on all the data set. And then we ran the test XT test 2. As you see, the probability is 0.80. So we cannot reject H0. We have to accept H0, and H0 is that there are no contemporaneous correlations. There are no cross-sectional correlations. So this is what we conclude in this test. Now we test for heteroscedasticity. You know that we have some usual problems in normal OLS regression as well, which are heteroscedasticity, autocorrelation, and multicollinearity. We can check for them here. So testing for heteroscedasticity is done by the command xttest3. Again, if you don't have it installed, or you write xttest3 or help xttest3 and you don't get results, you get an error message. This means you need to write a statement ssc install xttest3. So when you write ssc install xttest3, it will take some time and it will be installed on your machine, and you will get a message that it has been installed successfully. Then you can perform this test. So run a regression. It is a post regression command, and then with an H0 of homoscedasticity, that is a null hypothesis that there is no heteroscedasticity, run the xttest3 command and you will get your results. So first we run a fixed effect model, and then we write xttest3, and the results will be as you see. When we wrote xttest3 in this case, you see that the results show the modified Wald test for group-wise heteroscedasticity in fixed effect regression model. So this is related to fixed effect regression model. So probability greater than chi-square is 0, which means we have to reject H0. Remember that here H0 was that there is no heteroscedasticity, or the errors are homoscedastic. So this time we reject H0 and conclude that heteroscedasticity exists. Now remember what we did with the problems where we faced the problem of heteroscedasticity in OLS regression. We ran a robust regression. So here also you can run the regression with an option of robust. So the robust standard errors would be calculated, and the problem of heteroscedasticity will be no. It wouldn't be any problem. The next test is the Woolridge test for serial correlation. You can see it in the Woolridge textbooks, which we are using, the textbook. So this tests for serial correlation in panel data. So it is user defined and user created command. So you can again ssc install xt serial, and it will be installed. It is not available with the original version of Stata, or rather old versions of Stata. So whatever version you have, if you don't find the xt serial command already there, write ssc install xt serial and then perform the operations that I am going to tell you. So as you see some prerequisites of this test on the screen, we have xt set as a prerequisite, because xt serial is a command independent of whether you have ran the regression or no. So you'll see xt serial and give the variables with this command xt serial, log of wages and list of independent variables. So but with a prerequisite that you have already set the panel variables. So as you see, this implements a test for serial correlation in the idiosyncratic errors of a linear panel data model. So we are using linear models. So you can see it in the 2002 Woolridge development. So the null hypothesis is that there is no serial correlation, and the results you are seeing show the effect of writing this command xt serial log of wages, tenure, age, South and Union. So in this case, H0 was no first order autocorrelation. So remember that we may have second order autocorrelation or third order, but the test you have been doing, for example, the Durbin-Watson test, it also assumes that we are testing for the first order serial correlation or autocorrelation. Here also we are assuming that. So this command also assumes that, and the results which you see show a probability greater than f of 0.0028. which again leads us to conclude that we reject H0 at 5% or 1% level of significance and conclude that serial correlation exists. Now, what to do if serial correlation exists? There is a command in Stata, xtreg-ar combined without space, xtreg-ar. This is the command that you will use in case you find serial correlation or autocorrelation in your regression. So xtreg-ar fits regression models for panel data when the residuals have first order serial correlation. So you can use it simply as you use xtreg with the name of dependent variable and the name of independent variables, by using the in or if conditions, by using weights, and there are some options as well. If you want to know about the options, you can write help xtreg-ar and you will get the help window. As you know, this dialog shows you what the menu is, how can you use it through the menu, what the syntax of the command. We have two types of syntax here, one for fixed effect model, second for random effect model. So we can run this xtreg-ar for both fixed effect and random effect models in case you detect serial correlation in your data. Look at the syntax. For fixed effect, we write xtreg-ar dependent variable, optionally independent variables, optionally if and in conditions, weights if you need, FE and options. The difference in the random effect model is only that instead of FE, you write the command RE as an option to identify that you want to run a random effect model. So xtreg-ar offers a within estimator for fixed effect models and a generalized least square for random effect models. So it is effective both for running fixed effect models and random effect models. Let's see an example. So the example that you see is related to the same file you are already using. So I ran a fixed effect model. So you can see the results. So it is FE within regression with AR1 disturbances. This AR and 1 in parentheses means autoregressive order 1. So this means you are assuming that there is serial correlation of order 1. So if this is the case, then your regressions this time are estimated, your coefficients are estimated, taking care of this problem. As you see, the F is good, it is 0. This means we can think that the model is a good fit. You have the usual results as you get in xtreg, but this time you have additional rho AR. Look on the bottom of the table where you find sigma U and sigma E. You will find rho AR, autoregressive rho, and rho FOV. See, these are some additional things that you get. This is fraction of variance because of U and I. So you have usual correlation UI XB is minus 0.15. You have 3 types of R square. You get everything you get in xtreg, fixed effect or random effect model. But this time you had serial correlation of order 1 and you have applied a command that takes care of this problem. So use this if you detect serial correlation. This is a very easy method. So now you learnt about various tests that you apply, went into detail, you looked at the syntax. Let's take another example and quickly go through all the process and finally see what is the final regression that we must present. You will face some problems, we will find some remedy for those problems. So this is a very useful example and you will know about some more commands this time. For example, if you remember, if we have in the output window long display of results, then you have written, you see below more, then you click that and the display moves, this, it scrolls. So this time I am using a command set more off. This means that this more function is off. So this will run in an instant and you will see all the results. The window will not break or wait for your click to show the next results. So the first command that you see is set more off. This will set this function more off. Then we use web use. Remember that web use will download a file from the net, from the web, and load it into your memory. The file name is Grunfeld, and clear after comma states that you will clear the previous memory because you have been using a file previously and less work. If you have changed or modified something, it wouldn't work and you will get a message that data may be lost, you shouldn't load another file. So you use comma clear to specify that whatever data is lost, let it go. You need to load another file anyway. So in one command, you load the file and clear the previous data. Then you need xtset command. Remember that this command will set your panel and your variable related to your cross-sectional dimension and time series dimension. So look at this again. So xtset company and year, because to save time, I didn't show you describe and summarize statements. You will get all this data from panel example.do, this do file, which will show all the commands that I am going to show you. Remember that do files shows a list of commands. If you execute that, all the commands will execute in an instant, and then you can later on view them. You can create a log file as well, and then run this file, this do file. So when you run it, you will have your results, your output, and your commands as well stored in the log file. You can look at it later on. This is why I wrote in the beginning set more off, so that when you execute this do file, you have no problem. You don't need to click again and again and again to run various commands. So look at it again. So web use Grunfeld clear, then you xt set company and year, because when I tried to use the describe statement, I knew that the entity is company and time dimension is shown by the variable year. It is a strongly balanced panel, as you see. Strongly balanced panel means that you have same number of observations for each entity in the data. So there are, I think there wouldn't be missing values. And also you have a time variable. The year is from 1935 to 1954 with delta equal to 1, which shows that you have the year extends by 1 year. So the gap in time is 1 year. Next, we run a fixed effect model. You see the results. I'll quickly pass through these results. You have already discussed them. You have some market value and capital stock as independent variables, and your dependent variable is investment. So number of observations is 200. You have the same R squares within, between, and overall. You have an F value which shows a good fit. So you have sigma U, sigma E, and overall rho, the fraction of variance. So the coefficients 0.11 and 0.31 for market value and capital stock are both significant, which you can see from the column P greater than T. So this makes us conclude that 1% level of significance, these two coefficients are significant, and these two variables significantly affect the variable invest. So this was your fixed effect model. But remember that we performed a test to test for time related fixed effects. But for that you need to run another regression with an additional variable I dot the time dimension. In this case you have year as the time dimension. So you'll write I dot year. Look at the regression. You see another new command that I am going to teach you, QUI. In fact, this is a short for quietly. Quietly XT-reg investment and market value, capital stock, I year. So quietly means that you don't want to see the results of the regression because we are performing a test. I want to see the result of the test only. So if you write quietly do something, the process will be performed. You will get the results, but they will be not displayed in the output window of Stata because we are not interested in the model presently. I am interested in the test. So I write quietly XT-reg, dependent variable, independent variables, fixed effect, and then run a test. But this time, the test which we run has a prerequisite that we have given as an independent variable, I dot year, the index of the dot year. So you have dummy variables for all the years. The H0 was, as you remember, that the coefficients for all the years are 0. If this statement is accepted, this means that there are no time related fixed effects. So let's see what happens in this file. When we ran the command is test for test parameter I dot year. So you have from 1936 to 1954. These are your null hypotheses, all are 0. The probability greater than F is 0.13, so we cannot reject H0. So this time we have to accept H0 and conclude that there are no time fixed effect. You can do that at 5% or 10% level of significance. So the p-value, if it is greater than 10%, then you have to accept H0 and conclude that all the year related coefficients are 0 and you don't need to include any variable to capture the time fixed effects. Now let's move to the panel effects. If you remember, we used the command xtTest0. This makes a choice between OLS and random effects. So in this case, we want to know whether there are panel effects or no. So again, we have written quietly, QUI, quietly XT-reg, investment, market value, capital stock, random effect, RE for random effect, and the test is XT0. You see that the results show a probability greater than chi-square is 0, almost 0. So at 1% level of significance, we can reject H0 and conclude that panel effects in fact exist. We need to take care of that. There are random effects. We cannot use OLS in this case. So now usually we run an Ostman test, but remember that to run that you need to run a fixed effect regression, store the results, and then a random effect regression, and then store the results, and then run an Ostman test. See the results. So there are basically 5 statements. which you are seeing. The first one runs the regression. The second one stores the results in a variable in a macro named fixed. The third one again runs a regression, this time a random effect, and estimates store random stores the results of the random effect into the macro random. So Osman fixed random will run the test. So I have shown only the result of this fifth statement to save time. So the result shows that probability greater than chi-square is 0.3119. So we cannot reject H naught, that difference in coefficients is not systematic. We have to accept that random effects models are better this time. Now we tested for heteroscedasticity and serial correlation by the command xttest3 and xtserial. Let me tell you again, if you don't have these commands available, you need to write ssc install xttest3 and then ssc install xtserial, because these are user created commands. They are not part of basic stata. So let's run the test. Quietly xtreg invest m value k stock fe and then xttest3. This is a modified Wald test for group wise heteroscedasticity. The H naught is, as you remember, homoscedasticity. This means there is no heteroscedasticity. This time we have a p-value greater than chi-square equal to 0, which means we need to reject H naught and conclude that a heteroscedasticity exists. Remember that we are required to run the fixed effect model before that. The null hypothesis is homoscedasticity. In this case, we have rejected it. We can do that for the fixed effect model. And if you remember, as we have found we have detected heteroscedasticity. So what is the remedy? You just run a command with an option robust to calculate the robust standard errors. I leave it up to you. Now xtserial is a command for serial correlation, and you are seeing the example, the second file that we have been using. xtserial invest m value k stock. This doesn't require that you have ran some kind of regression before, but you are required to set the entity and time variables. This means by the xtset command. So this time xtserial invest m value and k stock gives a probability greater than f of 0. So we reject H naught. Remember that H naught here of the xtserial command was that there is no serial correlation. Since we reject it, we conclude that there is serial correlation. Now what to do? Remember that we in the previous example used a command xtregAR. This command calculates or estimates the regression, almost taking care of the serial correlation problem. So this xtregAR command can be run for fixed effect as well as random effect models. So I will show you results of one of them, of only the random effect models. So the results that you see run a random effect model, which is given by the option RE. But instead of xtreg, we have used a command xtregAR, which, if you remember, in case of random effects, it runs a generalized least square regression, and by assuming that the serial correlation may be of order 1. So you see it by the statement AR1 in parentheses, autoregressive of order 1. So if you have serial correlation of order 1, this will detect it. If you have of some other order, may not detect it. So in this case, the results that you see, you have a theta, you have rho r, the usual results of the xtregAR as you did in the previous example. You have the coefficients of m value and k stock which are significant. The constant value is just significant at exactly 10%. You have a Wald chi-square of 360 and a probability greater than chi-square of 0, which means that this is a good fit. So as you detected serial correlation, you need to run xtregAR. So remember that when you detected heteroscedasticity, you needed to use robust standard errors. Now in case of heteroscedasticity, you will use robust standard errors. In case of serial correlation, you will use the xtregAR command. But the problem is, as we may detect, both heteroscedasticity and serial correlation at the same time. So what to do? There is a solution. But before moving to the solution, let me revise everything a bit. The first thing you want to know, what is your data about? You will use the statements describe, summarize. Remember that some of them can be used with the xt preceding them, because this is a panel data, but you need to set it as a panel data. So the first thing you do is look at the data through usual describe and summarize and tab stat, know about your variables. Particularly, you should know about the dummy variables, continuous variables, what is your dependent variable, what are the nature of the independent variables. Maybe at the first step you realize that there are two variables such that there must be multicollinearity, so you avoid them, create another variable, transform them, or take some precautionary measures. So when you do that, then you have choices to run a pooled regression, that is an OLS regression, or run a least square dummy variable model, or run a fixed effect model, or a random effect model, or a between or within effect model. Within effect is the fixed effect model. So you have choices. You can use an option of MLE, of maximum likelihood estimate, in the fixed effect, or instead of fixed effect or random effect model. So you have many choices. Now the problem is how to decide about them. So we have described various tests to you which will clarify what is the appropriate or relevant type of regression to run. For example, in some cases you have some time related fixed effects. We did it by the xtTest0 command, when we ran a regression with i.year, if you remember. When we see that there are no time fixed effects, we don't need to use additional variables for that. Then we need to know whether there are random effects, there are panel effects or no. So we have a choice between OLS and random effect model, for example. Then we ran a test which specifies whether there are cross-sectional correlations. So we need to capture that. We need to estimate maybe the correlation matrix and use it. So you tested for fixed or random, choice between fixed or random effect. Then you tried to detect heteroscedasticity and serial correlation. But what we did was to deal with serial correlation and heteroscedasticity separately. So if you have heteroscedasticity, you will run a robust regression. If you have serial correlation, you will use the xtreg-ar command. But I was discussing what happens if you have both serial correlation and heteroscedasticity. You may face this problem. So you will come back to the xtreg command and use the cluster option. To know about the cluster option, you can just type help xtreg and look at the option and its description. Let me describe something of an example related to using this cluster option. Remember that in the cluster option, in parentheses, we need to give the name of the variable, which is the cross-sectional identification. For example, in this file, you have company as a variable which identifies the cross-sectional identity of the company. It must be a numeric variable, it shouldn't be the company name. So you have used this variable in the xtset command as well. So let's see how to use the cluster option with the xtreg command. So what you see on the screen is xtreg, invest, mvalue, kstock. These are the usual dependent and independent variables that you have been using in the tests. Comma fe, this is used with fixed effect. So you need to use the cluster option also this time if you have both heteroscedasticity and serial correlation. So when you use the cluster option, you need to give the individual ID variable as an input. So we'll write cluster, and in parentheses we'll write company, because this was the name of the individual. So in the previous example, the individual ID was ID code. So you would write cluster ID code, but this time it is company. So the complete statement would be, as you see, xtreg, invest, mvalue, kstock, comma fe, cluster, and within parentheses, company. So the results are robust in the sense that the standard errors are completely robust to any kind of serial correlation and heteroscedasticity. So the robust standard errors basically are used when we face the problem of heteroscedasticity, and the cluster command takes care of the autocorrelation. So in this second example, the final regression may be this one, in which we have again come back to the xtreg command, the basic command, but now with an option of cluster company. So this cluster option enables us to handle the problem of heteroscedasticity and serial correlation if you find them at the same time. So summarizing all this, you have various other tests as well. For example, if you just Google the Chow test, you will come to, you have various tests. But we have demonstrated a set of required tests that will make easy how to choose between an OLS or a random effect model, a random effect or a fixed effect model. It will enable these tests will enable us to detect problems like cross-sectional correlations, like heteroscedasticity, like serial correlations. You must check all of them. Usually you will find some of them, and you must know what to do in that case. For example, if you have time fixed effects, you will use some additional variables. To capture that, if you have heteroscedasticity only, not serial correlation, you'll use the robust option. If you have heteroscedasticity and serial correlation simultaneously in the same model, you will use the xtreg command with a cluster option. If you have only serial correlation, you will use the xtreg AR command. So I didn't tell you about various options that are available with the xtreg AR, etc., because I leave them up to you. Just type help and the command and you will get everything. Last thing, that if you don't have the commands available, the test commands xttest0, xttest1, just write ssc install xttest0 or xttest3. You should have your internet enabled and it will download and install automatically and you can use it later on. Thank you very much for today.